Part 2, here it is. Let's get to it. One more example, also worth up to 18 points on your next test. Crazy, one question worth 18 points. All right, so we're going to do example 1. By the way, example 1 is right above. We're going to do exactly what we did. So we're going to take this population of 2 and 3 and 7, but now we're going to sample without replacement. So let's go down and let's see what this will look like. So exact same pieces. Part A, find the mean of the population, mu. Find the standard deviation of the population, sigma. Find the mean of the sampling distribution of means, which is called mu sub x bar. And find the standard error, aka the standard deviation of the sampling distribution of means, and it is known as sigma sub x bar. Okay, parts A and B. Speaking of the population, will it change whether we sample with or without replacement? The answer is no. The population is the population. So the mean of the population is still going to be 4. The standard deviation of the population is still going to be 2.16. That has not changed. And look what I wrote here in a box on the right. Can be done on a calculator. Let me change that word can. Should be done on the calculator. All right, use the technology. If this were Algebra 1, I'd say crank it out by hand. But we're in honor stats. Let's use our technology to our advantage. So A and B doesn't change regardless of sampling technique. Part C. Now we're sampling without replacement. So that means once we draw the number 2 out of a hat, we cannot draw it again. So immediately 2 and 2, immediately 3 and 3, and immediately 7 and 7 all go bye-bye. They're gone. All right, here is what else can happen. So I could draw a 2 and a 3, but I could also draw 3 and a 2. I could draw a 2 and a 7, a 7 and a 2, a 3 and a 7, and a 7 and a 3. One thing about sampling without replacements, okay, I'm not going to use repeated samples. What does that mean on the left when I say don't use repeated samples without replacement? It means if I've drawn a 2 and then a 3, I don't have to draw a 3 and a 2. If I've drawn a 2 and a 7, I don't have to draw a 7 and a 2. If I've drawn a 3 and a 7, I don't have to draw 7 and 3. You know, Mr. Colodi, is it going to be incorrect if I do 2 and 3 and then 3 and 2? It will not be incorrect. You will actually get the correct answer. You'll just be doing more work than you need to do. So, as it is, I only have 3 samples, 2 and 3, 2 and 7, and 3 and 7. Now, let me slide up back to sampling with replacement. I want you to notice something. When we sampled with replacement, we did write repeated samples. So I'm going to double circle this. Even though we sampled 2 and 7, we still wrote 7 and 2. And I wrote this in a box right there. Please write all repeated samples when drawing with replacements. Okay. The other reason I slid up here is because with replacement, the number of samples that you get is big N raised to the little n power. That's how many samples, or in this case, 3 squared or 9. Let's go back down to example 2 now. How many samples should you get when drawing without replacement? The formula is not n to the n power, but rather big N C little n samples. Or in this case, 3C2, or just 3 samples. Again, is it something that needs to be memorized? No. But is it a great way to tell how many samples you should get without making too many or too few samples? Absolutely.
Yeah.
Okay, so we have 3 samples, all right, or big N, C, little n samples without replacement. The next process remains exactly the same. This is going to go super fast. Okay, so the average of the mean of 2 and 3 is 2.5. The mean of 2 and 7 is 4.5, and the mean of 3 and 7 is 5. Please don't do that too quickly. All right, I've seen more mistakes of more people finding just the sample means than anything else. So I'm going to take the sum of those sample means, and I'm going to find mu sub x bar. All right, it is the mean of those samples divided by the number of samples, which in this case is big N, C, little n. Formulaically, it looks difficult. It's not. It's just take the sum of that column and divide it by the number of samples. So 12 divided by 3 is 4. Wait a second. The mean of the population was also 4. The mean, oops, something happened here. I think, here we go. Let me scroll up. The mean of the samples with replacement was 4. Sounds too coincidental. We're going to find out very quickly here. All right, so now let's also find the standard error, aka the standard deviation of the sampling distributions. Sorry, everybody, for that little glitch. I think I pressed something and it highlighted the whole sheet. So the standard error is going to be, once again, the x bar squared column summed up. So in this case, take your x bars, square them, and sum them up, you get 51.5. So I'm going to take the 51.5, divide it by the number of samples, which is 3. And you're going to divide by the mean squared, which is 4 squared. And I get 1.08. That is my standard error. Just like number 1, if you can list your samples right here, that is worth 6 points on the next test. If you could find the standard error, that is worth 6 points on the next test. And if you could find the mean of the sampling distribution, that is worth 6 points on the next test. 6 and 6 and 6 is 18 points on your next test. This is crazy. Simply by using these formulas, and let's scroll to the bottom of the sheet. These are the formulas. They look very algebraic and formulaic. They're not difficult whatsoever. You take, with replacements, the mean of the sampling distribution. And by the way, there are big N raised to the little n samples with replacement. And you write all the repeated samples. That's very sloppy right there. Okay, big N raised to the power of little n. There are big N, C, little n samples when dealing without replacement. To summarize. And to find the mean of the sampling distribution with replacement, I just take the sum of all the x bars and I divide by the number of samples. To find the standard error, I take the sum of the x bar squares, divide by the number of samples, and subtract the mean squared. And I do the exact same thing without replacement. Ladies and gents, do this homework. Now, speaking of the homework, to finish up this lesson, I do believe that your homework consists of a population not of 3 numbers, but the population consists of 5 numbers, 2, 5, 6, 7, and 10. So the population for your homework, the population is 2, 5, 6, 7, and 10. That's 5 numbers. So capital N is 5, big N is 5. It says consider all samples of size 2 in your homework, so little n is 2. So I'm just going to give you a tip. Number 1 on your homework is with replacement. Number 2 on your homework is without replacement. So for number 1, you're going to have 5 squared, or 25 samples. You're going to make a list of 25 samples. And for number 2, there's going to be 5 C2 samples, and 5 C2 is 10 total samples. When you take a picture of your homework and send it to me, I want to see 25 samples for number 1, and I want to see 10 samples for number 2. And by that, I mean this list for number 2 right here is going to be 10 samples big. That's right, Sharon. And this list for number 1 here will be 25 samples large. Okay, everybody. Bye.